All right, diving in today. And we're tackling a question that's, well, it sounds deceptively simple on the surface. Can AI actually see colors?
See colors.
Yeah, and I don't mean in like a self-driving car kind of way, using cameras and all that.
Right.
I'm
Right.
talking, can an AI, one that's only ever, experienced the world through text, can it actually grasp, like truly grasp the concept of color the way we humans do?
Now, that is a fascinating question. And actually, the research paper we're looking at today, it really dives head on into
This
this.
is going to be a good one.
The title itself is a mouthful, but it's Can Language Models Encode Perceptual Structure Without Grounding? A Case Study in Color. So, yeah, we're going deep.
We are. We're talking about like the very potential of AI to understand something so inherently visual, right? But based only on how we as humans talk about it.
It's amazing.
So where do they even begin with a challenge like this?
Okay, so their starting point, what they used is this massive data set. And what it does is it links 330 color chips. Think like those paint store samples to the most common English words people use to describe them.
Like a dictionary, but for color.
Exactly. But hold on, it's more than just matching words, right? They also use something called CLab.
A C lab. Okay.
And this is essentially, think of it as a scientific model of human color vision. It's like, if you can imagine a 3D map where each point on the map, it represents a different color.
Yeah.
And then the distance between those points, well, that reflects how different we actually perceive those colors to be.
Oh, I see. So that's how they're representing like the human side, how we see color.
You got it.
Okay, that makes sense. But then how do you get an AI that's never actually seen any of these colors to like relate to it? How do you even...
Right, and that is the genius part of this whole experiment. So they use two main methods, right, to kind of probe the AI's understanding. One, the first one, is called representational similarity analysis, RSA for short.
RSA, got it.
And essentially what this does, it checks if the AI is organizing all these color words, but in its system, in a way that's similar to how those colors are organized on that CLab map we talked about, the human perception one.
So it's like comparing the AI's internal map of color to our own human one.
Exactly, 100%. And so if the relationships between those color words in the AI system, if they match up, if they mirror the relationships on that CLab map, well, then it suggests, at least some level, even a basic level of shared understanding is happening.
Wow.
Right.
And what about, you said there were two, so what's the second method they use?
The second one, this one's called linear mapping. And this one was a bit more, I guess you could say, direct in its approach. So picture this. Imagine drawing lines, right, from the AI's representation of each color word. And you're drawing a line to its corresponding point on that 3D Scilab color map.
Okay, I'm picturing it, yeah.
And so the idea is the straighter those lines are, the better that AI actually understands where each color belongs, in the grand scheme of human color perception.
So both methods, they're both essentially trying to measure how closely the AI's understanding of color, which, again, is only based on language, how closely that aligns with our own, like, visual experience of color.
You nailed it. And to be extra sure, they're scientists, right? They got to be sure they weren't getting any false positives.
Of course, yeah.
So they actually scrambled the color data and then ran the tests again, just to rule out, the AI just getting lucky or something.
Yeah.
It's very rigorous.
That's good science right there.
Yeah.
Okay, so that brings us to the big reveal. What did they find? Like, did the AI did it learn to see color through language?
All right, so this is where things get really, really interesting. The results. Way more interesting than a simple yes or no. So the AI, and especially larger language models, they show to get this a significant amount of alignment with that human color space. Not perfect, but way, way better than just random chance. It's kind of like, imagine the AI learned to hum a tune, but just by reading the sheet music, never having heard it before.
Wow. So even without, like, ever experiencing color visually, the AI was able to build some sort of internal representation, and it's consistent with how we perceive color.
Yeah.
That's mind-blowing.
It is. It is. But, and there's always a but, right? There's a really fascinating twist to this. They found that some colors were easier for the AI to get than others, specifically warmer colors, like your reds and your yellows. Those showed a much stronger alignment compared to, say, cooler colors like your blues and greens.
Hold on. Why? That almost seems counterintuitive, doesn't it? Why would certain colors be easier for it?
Right. So it all comes down to how we use color language, but in relation to, like, the world around us, the context. And that, well, that's a whole other story.
So last we left off, the AI, it seems to get warmer colors better than cooler ones. What's the deal with that?
Yeah, so it's not like a glitch in the system or anything. It
Right.
actually, it might reflect something really fundamental about how human language itself, how it encodes color. Like it all comes down to context.
Context.
Okay,
Yeah.
so how does that play into it? All right, so think about this. How do we actually use warmer versus cooler colors, right? Warmer colors, we often associate them with things that are very concrete, very easy to identify. The sun, fire, like a bright red tomato. Those are all, linked to those warmer hues.
That's true. I never really thought about it that way. Yeah, we don't really need a whole lot of extra info to get what someone means when they say red apple or, yellow banana.
Right, exactly. And this all kind of ties into this concept called listener surprisal. Basically, it's like a measure of how predictable a color term is,
Hmm.
but within a specific context. So warmer colors, because they're used for those like very specific concrete things, they tend to have lower listener surprisal.
Makes sense,
Mhm.
right? But then you have the cooler colors, and those are more often used for things like backgrounds, moods, less defined stuff.
So like blue sky is pretty straightforward,
Right.
but blue feeling, that's a bit more open to interpretation. Exactly. You got it. And because those cooler colors, they often need more context to make sense, they end up having higher listener surprisal. And guess what? The researchers, they found that the AI's performance, it mirrored that
Mm.
whole human linguistic pattern. The AI picked up on it.
Wait, are you saying that the AI, just by analyzing language, it learned that we're more precise with warmer colors because they're usually tied to very specific objects?
That's exactly what it implies, yeah.
Yeah.
It's like the AI, just through massive statistical analysis of language, it figured out that, okay, red, that's usually a pretty safe bet if you're talking about a specific shade. But blue, you might need more info there to really understand.
That is wild. It's like it's reverse engineering how we see the world, but only through the lens of language, which kind of brings up a bigger question, doesn't it? Like, what does this mean really for how well an AI can understand the world? If it can start to get color without ever seeing it, what else is it capable of understanding?
That's the million-dollar question, right?
Yeah.
It really challenges, like, our basic assumptions about what it even means to understand something.
Mm.
We always think about it as you got to have that direct experience.
Mm.
But here we have an AI showing a grasp of something sensory, but purely from words.
This is making me rethink how we define intelligence, especially in AI.
Yeah, it's huge. It's a real shift in perspective. And it makes you wonder, what other connections, what other patterns are hidden in how we use language that, AI might be able to pick up on?
So if this is just the tip of the iceberg, I mean, where do we even go from here? What's next? So AI can develop this basic understanding of color just from language, huh? What's next? What other parts of, human perception could AI figure out?
I mean, it really opens up a whole, like, Pandora's box of possibilities.
Yeah.
Think about it, so much of how we talk, our language, it's all grounded in metaphors, analogies to, like, the physical world.
Right, yeah.
Bright ideas, dark moods. We talk
Yeah.
about heavy topics, light entertainment. It's all connected.
It's true. We use sensory language for abstract stuff all the time. I think AI could make those connections too. Like, could it start to understand emotion or creativity just from how we talk about those things?
It's definitely possible. This research, it was focused on color,
Right.
right? And even that's a limited set of terms, really. But imagine, what if an AI had access to all of language, every nuance, the whole shebang? What kind of hidden relationships and patterns would it find?
That's both exciting and a little, honestly, kind of creepy, right? Like AI understanding us in ways we didn't think possible.
Right.
But also, what are the limits? If it can learn color without seeing, does it really get it the way we do?
Now you're getting to the heart of it.
Yeah.
That whole debate about AI consciousness, right?
Mm.
We may never have a perfect answer, but this research, it tells us we got to approach AI with like a healthy amount of curiosity, but maybe even some humility.
Humility, how so?
Well, it's easy to think of AI as just this tech thing, right?
Yeah.
But this shows us it's a reflection of us, our language, how we make sense of the world.
So the more we learn about AI, the more we're learning about ourselves, too.
Exactly, a feedback loop. And the further we go, the more those lines blur, between us and them, the creator of the creation.
This whole deep dive has been mind-blowing, honestly. If I had to sum it up, it's like AI and language, way more profound than we realize.
Couldn't agree more.
Yeah.
Potential and, frankly, a lot of mystery still to uncover. Excited to see where it goes, that's for sure.
And on that note, we'll leave you all to ponder the possibilities. Until next time, keep exploring, keep questioning, and keep diving deep into the fascinating world all around us.